Okay, chapter 4. Um, what are minerals? And or minerals in section 1. What are minerals? These are the notes. Here's the essential questions you'll need to answer. How are minerals defined? How do minerals form? And how are minerals classified? And here you see a couple dozen minerals under a fluorescent or black light. Review vocabulary is element, minerals. New words are mineral, crystal, luster, hardness, cleavage, fracture, streak, and specific gravity. So, mineral characteristics. Earth's crust is composed of about 3,000 different minerals that play important roles in forming rocks and in shaping Earth's surface. And here again, you see a collection of minerals. A mineral is a naturally occurring inorganic solid, never living. Okay. It has to also be naturally occurring for it to be a mineral. We can make minerals like diamonds, but those are man made and not naturally occurring. So they're not considered a mineral. So a mineral is a naturally occurring inorganic solid with a specific chemical composition and a definite crystalline structure. If you looked at the lecture, you know that all matter is divided into two groups. There is pure substances, and there are mixtures of pure substances. This right here, um, a definite crystalline structure. These are pure substances known as compounds. Minerals are compounds. A group of minerals makes up rocks. All right, mineral characteristics naturally occurring and inorganic. Minerals are naturally occurring, meaning that they are formed by natural processes, and all minerals are inorganic. They are not made from living organisms. Mineral characteristics, definite crystalline structure. They have a definite structure. The atoms in a mineral are arranged in regular, repeated geometric patterns that result in the formation of crystals. And here you can see a crystal that is formed. A crystal is a solid in which the atoms are arranged in a repeating pattern. They have a definite chemical formula. Solids, mineral characteristics. And remember, when we're talking about characteristics, if we can go back when you were in my physical science class, we talked about different properties, mineral characteristic or mineral properties. Each mineral has its own properties, just like I Spy, color, shape. And this is what we're looking at here, the characteristics of a mineral that would be their I Spy. If we were playing I Spy, you could describe these minerals by their characteristics, okay? So minerals are solid and therefore have definite shapes and volumes. Each type of mineral has a chemical composition unique to that mineral. A few minerals are composed of single elements, however. The majority are made from compounds. In some mineral, right here, for example, gold. Gold is a mineral, it's an element. In some minerals, such as varieties of feldspars, chemical composition can vary within a certain range, depending on the temperature at which that mineral crystallized. So, different temperatures give us different characteristics. I just love this picture. I used it again here. 8 to 10 of the 30 most common minerals are referred to as rock forming minerals because they make up most of the rocks in Earth's crust. Rock forming minerals are primarily composed of 8 most common elements in Earth's crust. All right, rock forming miracles. Rock forming minerals. Minerals form from magma. Molten material that forms and accumulates below Earth's surface is called magma. Magma is less dense than the surrounding rock, so it can rise upward into the cooler layers of Earth's interior. There, it cools and it crystallizes. The type and number of elements in the magma determine which materials will form. The rate at which the magma cools determines the size of the mineral crystals. Small crystals form from rapidly cooling magma, and large crystals form from slowly cooling magma. The faster the magma cools, the smaller the crystals. If it cools really fast, we get what's called glass. Okay, there's literally no crystal formation. It's just a bunch of atoms, and it's known as glass. The longer time it has to cool, the larger the crystals are. Matter of fact, um, Yellowstone, where we have all those hot springs in that, the magma is still cooling under the ground there. All right, that magma is what causes all those hot springs in that, and there's long term cooling. If you didn't notice, check the guy out right here. Yeah, I would say that's a little warm. Anyway, minerals from solutions. A liquid is saturated when it becomes full of a dissolved substance and can dissolve no more of that substance. If more of the substance is added to the saturated solution, it is called supersaturated, and mineral crystals form into solids from the solution. Minerals that form from the evaporation of the liquid in which they were dissolved are called evaporates or evaporites. Um, Hydrothermal solution. And here's a picture of solution. Okay, the very hot, watery solution that escapes from a massive magma during the later stages of crystallization. Such solutions may alter the rock surrounding rock. But anyway, here you go. Here's a heat source. Okay, and there is a solution there. Hydrothermal solutions, water mixed with a bunch of minerals in here, and you can see they will start to form deposits as they cool off, as they evaporate. They leave behind their mineral contents. All right, and here you see some mineral deposits. Here are some mineral deposits starting to form. Okay, so identifying minerals. If you pick up a mineral, how do we know which is which? Okay, and we know this by um, their properties, their physical properties. Geologists identify minerals using tests based on a mineral's physical and chemical properties: crystal form, luster, hardness, cleavage, fracture, streak, color, specific gravity, texture, density, and special properties. Here is, if you were in the classroom with me right now, this is what we'd have. You got a little magnet here. You got what's called a streak plate, a nail. I know what's a nail doing in there. You'll see a glass plate and a magnifying glass and a um, little bottle of acid. Okay. Identifying minerals. You can identify a mineral by its crystal form. Some minerals form such distinct crystal shapes that they are immediately recognizable. However, perfect crystals are not always formed, so identification based only on crystal form is rare. Every now and then you can pick it up. You can pick up a mineral and it'll be perfect. It doesn't happen all the time, but it can. All right. So, crystal form is one way to identify, but if that doesn't, if we can't get our complete answer, then we'll go on to the next step, which is luster. The way that a mineral reflects light from its surface is called luster. There are two types of luster: metallic luster and non metallic luster. Luster should usually be used in combination with other physical characteristics to identify a mineral. Okay. And here's different types of luster. Here's a metallic luster. This is a dull luster. Waxy, it looks like a piece of wax. Pearly luster, earthy luster, and different types of luster. So you can go by crystal, and you can see right here, look at the crystal shapes in these. But they're not perfect. These crystal shapes are not perfect. So we could look at the luster and crystal shape. Okay. The next property is hardness. How hard is that um, mineral? Hardness is a measure of how easily a mineral can be scratched. You can take, if you can scratch it with your fingernail, it's either gypsum or talc. If you can do it with a penny, a copper coin, it's going to be one of these three. If you can do it with a knife or a nail, or if it scratches, if glass scratches the mineral, it's going to be apatite down to talc. It's going to fall in here someplace. Here's where your nail comes in. 6. All right. You can see if it'll scratch with a nail. If it doesn't scratch with the nail, we're going in this direction. It's going to be up in here. All right. German geologist Frederick Mohs developed a scale by which an unknown mineral's hardness can be compared to the known hardness of 10 easily recognized materials that, with an exception of diamond, are readily found in nature. And I told you before during the lecture, talc, gypsum, calcite, fluorite, apatite, feldspar, quartz, topaz, corundum, and diamond. Tall girls or guys can flirt, and 4 quaint things can do. Those are my first letters, and that will help you remember the order of Mohs hardness scale. All right, so cleavage and fracture. A mineral that splits relatively easily and evenly along one or more planes of weak atomic bonds is said to have cleavage right here. All right. You will also get them breaking up like this according to their chemical bonds. To identify a mineral based on cleavage, geologists count the number of cleavage or cleaved planes and study the angle or angles between them. Minerals that break with rough, arc-like, or jagged edges because of their tightly bonded atoms are said to have fracture. All right, so these all indicate cleavage, but some will fracture. They have no cleavage at all. All right, here would be a fracture. You see there's no squared edges anywhere, where here there's a lot of them. Here there's a lot. Here there's a lot of these edges, but then you also have fracture where you do not have those angles and edges. Streak. Streak is a color, and this is another identifying property. Streak is the color of a mineral when it is broken up and in powdered form. The streak test, which typically involves rubbing a mineral against an unglazed porcelain plate, is most useful in identifying metallic minerals. It can be used only on minerals that are softer than the porcelain plate. But you can see here's a piece of pyrite. It is a brassy yellow color. It's fool's gold. Okay. And when we streak it, even though to our eyes it looks that brass, that goldy color, when it's in powder form, its actual color is black. It's a trick of the light. Okay. A trick of the light. Color is one of the most noticeable characteristics of a mineral. It is also one of the least reliable clues of a mineral's identity. For example, again, this to me looks like pyrite or fool's gold. You cannot go by the color because its real color in powder form is black. You cannot go by the look of the look or color, I should say, the look of color in a mineral. You have to see it in its powdered form. All right. Minerals have special properties. Several special properties of minerals can also be used for identification purposes. Some of these properties are magnetism, iridescence, double refraction, effervescence with hydrochloric acid, and fluorescence. So, like this mineral right here, obviously it's magnetic. Okay, it has a magnetic property to it that'll help us to identify it. That very first page right here, these fluoresce under a black light. They change cool colors. All right. We can identify them by that also. So, different ways of identifying minerals. Texture. Texture describes how a mineral feels to the touch, and like luster, is subjective. It is often used in a combination with other tests to identify a mineral. And these are close up surfaces of some minerals, and they give us different textures. Density and specific gravity. Two minerals of the same size may have different weights due to the difference in density. And remember, density is a measurement of how close the particles are together. Density reflects the atomic mass and structure of a mineral. Density is expressed as D equals M over V, where density, D is density, M is mass, and V is volume. These should actually be lowercase letters. Because density is not dependent on size or shape of a mineral, it is a useful identification tool. The most common measure of density used by geologists is specific gravity, the ratio of mass of a substance to the mass of an equal amount of water at 4 degrees Celsius. You have to have a cooling apparatus to keep the water at 4 degrees Celsius. So, unless you're a scientist and you have access to lab equipment, that's kind of a moot point. Okay, so how are minerals defined? How do minerals form? How are minerals classified? You should know the answers to these. If you don't, get back in that book and study. Watch these notes again, look at the lecture. Vocabulary: mineral, crystal, luster, hardness, cleavage, fracture, streak, and specific gravity. All right, I hope that helps with your homework, helps expanding your knowledge.